11.2, types of chemical reactions. There are 5 different types of chemical reaction, guys, we're going to talk about. The first one's called combination. And if you look at this, a combination reaction is one where 2 elements come together to form something else. In this case, we have magnesium, coming together with oxygen to form magnesium oxide. You have 1 element, 2 elements coming together to form 1 compound. This is a combination reaction. You may also hear it being called a synthesis reaction. Sometimes they use synthesis means to make something instead of combination. All depends what book you have. Okay. Now let's take a fun kind of look at this. If you were to put this reaction with relationships like I always do, combination reactions like this. Here's A. We have Mr. Happy Guy. And there's B, a lonely girl. And they get together and they become a couple. So A plus B will give you AB. Now if you look back to where we were last time, this would be the A plus B will give you AB. Okay? A plus B yields AB. That's a combination reaction. Very simple. Okay. Second is decomposition. A decomposition is just the opposite of combination. It's where a reaction breaks down. So you have HGO, mercury 2 oxide, with heat. See the little heat sign? So I'll put the delta. I like the delta sign. Little delta. We're using heat to break it down into mercury and into oxygen. So we would say AB decomposes to A plus B if we were to look at it with the relationship. And just like last time, here it is. We have a breakup. Here's our happy couple. And of course he probably said something wrong since, I have to take the girl's side. And what happens? A is left behind and B walks away. The 2 split up. They decompose as a couple. Decomposition reaction. Next is the single replacement reaction. Now single replacement is a little bit more difficult. Combination and decomposition are pretty straightforward, but single replacement is a tad bit different. Now, the single replacement is just that. Let's look at this. We have potassium plus water, and I'm going to write it HOH so you can see what I'm doing. It says H2O. H2O can be written as HOH. Now, what we have is a metal, and it's a cation. This is going to be my anion. This is going to act as a cation. The cations, the potassium and hydrogen, are going to switch places, a single replacement. So what's going to happen is this. Potassium is going to come together with hydroxide, and hydrogen will be by itself. So potassium will come over here and hook up with the hydroxide, and the hydrogen will be by itself. But notice I had to put the 2. It's a diatomic molecule. Okay? Now when we look at single replacement reactions, we have to look at something called the activity series, and we'll be doing a lab on this after this section. And this activity series of metal tells us how these are going to react. What can replace what? It says decreasing reactivity. What that means is silver is the least reactive of the elements. Okay? Very, very, very low reactivity. Lithium is one of the highest. So if I have, here's my potassium, okay, plus HOH. Since potassium is above hydrogen, it can replace it. Since potassium is above hydrogen, it's more reactive than hydrogen, that's why we can get potassium hydroxide plus hydrogen gas. Now, if I would have something like this, where I had silver plus iron chloride, when I put these together, silver is beneath the iron. Therefore, no reaction will happen. Silver cannot replace iron. It is less reactive. So something has to be more reactive in order to replace it. And if we look at our relationship here, here's how we see our single replacement. It says displacement here. It can be displacement or replacement depending on which book you read. But this would be my potassium. This would be my H. C would be OH. And notice now how we have H2 by itself. The B is now by itself. And the KOH is together. Okay? You have a single element to begin with and you have a single element to end with, but they're two different elements. A sneaks in here while this lovely BC couple is dancing, and an A goes off with C and leaves poor B behind. Okay? So, single elements, different single elements at the end. Okay? And you have to look at your activity series to make sure it's going to work. Now, the next is called a double replacement reaction. And this is where we have two compounds. This one has K2CO3, I'll write a little bit bigger, K2CO3 plus BaCl2. Now what's going to happen is this K, which is a positive ion, remember positive, negative, is going to come over here and hook up with the chlorine to get KCl. Then the barium is going to come over and hook up with the carbonate, and we'll get BaCO3. And that's basically all you have with it. They just switch places. It's a double replacement, okay? Two elements switch places, and you get two new compounds. So if you look at it from the relationship standpoint, oh, it's a free-for-all here. So you have AB, here's one couple, here's another couple. Well, they decide they're going to switch partners and have more fun. So D goes with A. D and A make a new couple. And B goes with C. Like she's about ready to do the burning, doesn't it? Okay? So we have two new couples here. A and B, D and C originally, then DA and BC. Notice we have a positive and negative. I lied, excuse me. Boys are negative. I can live with that. Just kidding. So I have the negative with a positive and a negative with a positive. Okay? So they just switch. You cannot have two positives or two negatives together. And it's called a double replacement. Now combustion is our final type of reaction. Combustion reaction is whenever you have a hydrocarbon. Hydrocarbon is a carbon with a hydrogen, hence the hydrocarbon, and it reacts with oxygen. So methane, CH4, and here's oxygen, O2. And whenever these two react, you get carbon dioxide and water. Every combustion reaction will always make this. I don't care if I have C6H14 plus O2. You will always get carbon dioxide and water. I don't care if I have C212 or 202 in hydrogen 300, if that's impossible, plus oxygen. You're going to make CO2 plus H2O. These are the final products for a combustion reaction. Always, 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 always. Okay? Now, in combustion reactions, make sure you realize that you have to have oxygen with a hydrocarbon. Okay, now you're going to be able to predict what type of products will be formed based on what type of reaction it was. So the type of reaction, as it says, is a good indicator is what products will be formed. I have a compound and a compound. If I have a compound with a compound, it's going to be a double displacement or replacement, however you want to say it, reaction. Here's my A, here's my B, and this is my C and my D. These two just switch places, okay? So when you have a double displacement, the calcium comes over and hooks up with a nitrate right here, and then the mercury comes over and hooks up with the iodine. But you have to write new formulas for this, guys, okay? You have to make sure you check your formulas. CAs plus 2, nitrates minus 1, crisscross. Make sure your formulas are correct. Mercury's plus 2, iodine's minus 1. You have to make sure it's correct, okay? What if I had something like this? Let's go down the next page with a little more room. Okay, let's say I had calcium plus oxygen. Well, single element must be a synthesis or combination reaction. It's going to make calcium oxide. Now notice that 2 did not come over here. This is where I have to balance my equation. I'd put a 2 there, I'd put a 2 here, and a 1 there. Now it's a balanced equation, but that 2 goes with the diatomic oxygen. It does not go with the calcium oxide. Okay? Let's see. Let's try another one. Let's try, let's see. Lithium plus calcium sulfate. Well, if I look back at my activity series, I see that lithium is most reactive, so it's going to replace this. So this lithium is going to come over to single replacement. I have a single element and a compound. That means it's going to be a single replacement. So that lithium is going to come over and hook up with the sulfate. I'm going to get Li2SO4. I have to redo my formula, plus calcium all by itself. Single element here, single element there. Okay? Now you're going to be working on practicing completing reactions. Good luck!